One of the things calculus is going to allow us to do is find where functions have maxes and mins without using our calculators. And so it's the derivative that kind of reveals this information for us. And so we'll want to take a look at what values of the derivative are going to tell us whether or not a function may or may not have an absolute max or an absolute min, or a local max or local min. So I have a definition here, a critical point. A critical point is an interior point at which the derivative is 0 or the derivative is undefined. So let's just take a look at my graph here that I sketched on the left. Let's call this f of x, I guess. So it looks like here at 1, something interesting is happening. It's an interior point, and it looks like the derivative is 0. So we have to claim that there is therefore a critical point at x equals 1. At 3, we have that the derivative does not exist. It's an interior point. So we have a critical point at 3. And then at 4, the derivative doesn't exist, and it's an interior point. So we have critical points at those 3 locations. Now notice I've got a min rather, at 1, a max at 3, and I've got neither a max nor min here at 4. So just because you find a critical point doesn't mean you found a max or min, but we're going to see that those are that if there is a max or min in the interior, it's going to happen at a critical point. So I'm just going to note that at the top. We'll say extreme values only occur at critical points. Now I'm going to put or here. I want you to think for a second, where else can an absolute max or where else can an extreme value occur? And if you look at the previous video, we saw that they can occur at endpoints. So or endpoints. But those are the only 2 options. Either you have a max in an interior, max or min in an interior, and those will occur at critical points, or that max or min is going to occur at an endpoint. A stationary point is just defined to be an interior point where the derivative is 0. So in this graph here, I've got a stationary point at A. And I've also got one at B, because the derivative is 0 at both those instances. Again, make sure you take note of the fact that in this case we found an extreme value at B, but at A, there is no extreme value. So just because you found a place where the derivative is 0, that does not mean you found a max or min. You have to do some further analysis. However, if a function has a local max or local min at an interior point, and the derivative exists, so that rules out in this top left graph, for instance, at instances at 3 and 4, if the derivative exists, well, then that derivative must be 0. All right. So anytime you know the derivative exists and you have an extreme value, the derivative must be 0 at that instant. All right. So a simple sketch here, maybe. Right, here's C. I've got a min here. The derivative exists, that this curve is changing smoothly. So we can see clearly that that's happening where the derivative is 0. All right. So the general process when you're finding maxes and mins of a function is you find the derivative, you find those critical points where the derivative is equal to 0 or where it doesn't exist, and then you need to analyze the behavior around those critical points to determine whether or not you have a max or min. So we'll do that in a future video.